Welcome to AI for Kids. Artificial intelligence, AI, is transforming various fields including healthcare and medicine. It has the potential to revolutionize the healthcare industry by making diagnoses more accurate, treatments more personalized, and patient care more efficient. In this video, we will explore the impact of AI in healthcare and medicine. One of the most primary applications of AI in healthcare is medical diagnosis. AI algorithms can analyze vast amounts of medical data and provide faster and more accurate diagnosis than traditional methods. This is particularly helpful in areas such as radiology, where AI can analyze medical images, detect abnormalities, and identify potential diseases. AI-powered diagnostic tools can also help doctors make more accurate and timely diagnoses of conditions like cancer and heart disease, leading to better patient outcomes. Another area where AI is making significant strides is personalized medicine. AI algorithms can analyze a patient's genetic data and medical history to identify personalized treatment options. This approach is particularly useful in the treatment of cancer, where different patients may respond differently to the same treatment, with the help of AI, doctors can identify the most effective treatment options for each patient, leading to better treatment outcomes and fewer side effects. AI is also helping to improve patient care by enabling remote monitoring of patients. AI-powered devices can monitor patients' vital signs such as heart rate and blood pressure in real time and alert healthcare professionals to potential problems. This is particularly useful for patients with chronic conditions such as diabetes or heart disease, who need continuous monitoring and care. AI is also being used to develop new drugs and treatments by analyzing vast amounts of medical data. AI algorithms can identify potential drug candidates, predict their efficiency and side effects, and optimize dosages. This approach can help reduce the time and cost of developing new drugs, making them more accessible to patients, despite the numerous benefits of AI in healthcare and medicine. There are also potential drawbacks. One major concern is the accuracy and reliability of AI algorithms. While AI can analyze vast amounts of data, it is only as accurate as the data it analyzes. If the data used to train an AI algorithm is biased or incomplete, the algorithm may provide an inaccurate or unreliable results. Another concern is the ethical implications of AI in healthcare. As AI becomes more prevalent in healthcare, there are risks of replacing human healthcare professionals, leading to job losses and reduction in the quality of care. There is also risk that AI will be used to make decisions about patient care without human oversight, raising concerns about accountability and transparency. In conclusion, AI has the potential to revolutionize healthcare and medicine by improving diagnosis, personalizing treatment, and enabling remote monitoring of patients. While there are potential drawbacks to the use of AI in healthcare, the benefits are too significant to ignore. As AI continues to evolve, it will be crucial to ensure that it is used in a way that is ethical, transparent, and accountable. By doing so, we can unlock the full potential of AI in healthcare and medicine, improving patient outcomes and transforming the healthcare industry. Computer vision and image recognition are two closely related fields in computer science that involve automatic analysis, interpretation, and understanding of digital images and videos. With the increasing availability of digital image data and the exponential growth in computing power, these fields have become increasingly important in a wide range of applications, from self-driving cars to medical imaging. Computer vision is the science of enabling computers to interpret and understand images and videos in a way that is similar to human perception. The goal of computer vision is to extract relevant information from images and videos to perform a variety of tasks, such as object detection, tracking, recognition, and 3D reconstruction. This field involves the use of techniques from image processing, pattern recognition, and machine learning to analyze and interpret visual data. Image recognition, on the other hand, is a subset of computer vision that involves identifying objects or patterns with an image. Image recognition systems can be trained using supervised learning techniques to identify specific objects within an image, such as people, animals, or vehicles. These systems can also be used to identify patterns or abnormalities within images, such as identifying tumors in medical images or detecting fraud in financial transactions. One of the most common techniques techniques used in both computer vision and image recognition is deep learning. Deep learning is a subset of machine learning that involves the use of artificial neural networks to model and solve complex problems. These neural networks are trained using large amounts of labeled data and can be used to recognize patterns and make predictions. One of the most significant challenges in computer vision and image recognition is the variability and complexity of the visual data. Images can vary in terms of lighting conditions, background clutter, object pose, and occlusion. These variations make it difficult to develop algorithms that can reliably detect and recognize objects within images. To address this challenge, researchers have developed a variety of techniques including feature extraction, object segmentation, and convolutional neural networks. Feature extraction involves identifying specific features within an image, such as edges or corner, that can be used to describe the image's content. These features can be used to classify images or identify specific objects within images. Object segmentation involves dividing an image into different regions based on their content and extracting features from different regions. Convolutional neural networks are a type of artificial neural network that is specifically designed to analyze and classify visual data. These networks use a hierarchical architecture that allows them to learn increasingly complex features from the input data. Computer vision and image recognition have a wide range of applications in many industries. For example, self-driving cars use computer vision to identify and track objects on the road, including other vehicles, pedestrians, and traffic signals. Medical imaging uses image recognition to detect diagnoses, diseases, including cancer and heart disease, and sometimes even tumors. Retail companies use computer vision to analyze customer behavior, and track inventory. Security companies use image recognition to detect and identify potential threats in video surveillance footage. In conclusion, computer vision and image recognition are rapidly growing fields that are essential for analyzing and interpreting digital images and videos. These fields have many exciting applications and offer significant opportunities for researchers, developers, and businesses to create new products and services. As the amount of digital image data continues to grow, computer vision and image recognition will become increasingly important for many industries, and their impact on our lives will continue to grow. I hope you enjoyed learning about AI in healthcare, image recognition, and computer vision. I'll see you tomorrow.